Hello everyone, good evening everyone. So we welcome you all to Sri Chaitanya Education Institution. Okay, so here we are going with the same thing again, and that's the last mock practice session we can say for the grade 7th physics. Okay, so already we have been studied a lot about the topics and everything. Yeah, hi Anuj, hi. Okay, so just let me know whether this communication of the English one is the correct, or do you want in the Hindi also? So you can just let me know. In the previous class, I just got the one of the comment regarding it. Okay, so we can do that, no issues. ठीक है, तो क्या कर रहे हैं फिर से हम देख लेते हैं वापस. ठीक है, in Hindi also I'm just telling you. So we are preparing it for the India's largest scholarship examinations, that is SCORE. ठीक है, by Sri Chaitanya. Yes, okay. So in the today's session, what we will going to do is we are taking some n number of questions. Already we have discussed most of the topics, we have done it. ठीक है, जितने भी topics आने सारे we have discussed it already. Now we have to do the final revision of it. ठीक है, if you have not watched the topics, go to the playlist from the YouTube channel, see it, do the practice from there. Okay, so you'll see the concept is also along with each and every question is being given. Okay, so the thing is, first of all, again, this is the SCORE scholarship examination, which is the India's largest, with the having a 2.5 crore of cash rewards and the 350 crore of scholarship. Yeah, and that's the one of the interesting thing from me also. It is that is the NASA trip and exciting gadgets and all. Okay, and 100% scholarship up to has been there. So I think you all have been just watched the session. If not, do watch the session from the playlist. Okay, I told you already. Okay, so basically it's a national level scholarship examination for the grade 3 to 12 conducted by Sri Chaitanya. Online, offline format, it has been there, and the lots of prizes and gifts and everything, gadgets has been there. Okay, then 100% scholarship, cash prize, rewards, I told you everything. Dates are very important, everyone. Just see this one, dates. That is the test one for SCORE is 28th of September. That's going to become soon, and the last date for registering is 26th of September. So still you have the timing for register yourself. Then SCORE test date, second one is of 12th of October, and the last date for registering is 10th of October. Okay, so these are the dates which is important for you. Okay, clear? So let's come to the physics. So let's start it, okay, with the lots of energy and everything. So here we are completing the physics complete syllabus final revision mock test 4. That is a part of it. So this is the question number 1 we are having on my screen. That the car moves 60 km in the first hour, 50 km in the second hour, and 70 km in the third hour. What kind of motion is this? Easiest question, not that much tough, but the point is question may come from the topic like uniform, non-uniform motions and all. Okay, so this we can see it, right? Okay, so let's see how to solve this type of the question basically. So you can see the first distance given 60, then given 50, then given 70. Three distances are given to us, that is 60 km, 50 km, 70 km. Can you see this one thing? 50, 60 and 70 is not equal distances. So these are unequal distance. Okay, and the timings you can see 50 in the second hour, first hour, and the third hour. Okay, clear? So that means timing is equal. So the motion of a body which used to move equal interval of time but in unequal distances. So unequal distance is traveling in equal amount of time. That type of motion is called to be non-uniform motion. Clear? If it's said to be that equal distance in equal interval of time, then it's called to be uniform motion. Circular motion, vibratory motion, we know that's the vibratory is the oscillatory one motion, that is to and fro movement. Okay, circular is the rotational one, okay, where this one must be having some radius and all. Okay, so I hope this much has been clear to all. So this is the basic easy question. Now maybe they're going to ask you about the graph also. So if the graph you are having it, that's the distance time graph. Okay, and if it's a straight line, that's been the uniform motion. Okay, and if it is not the straight line, any curve, any sort of the curve, not the straight line, for distance time, then it's called to be the non-uniform motion. Clear? And for the circular one, we have already done the question for the circular one, and that's what if you have to find it, the circumference of it, that will be, this radius is r, so it will be 2 pi r. Okay, in that terms. Clear? So I hope so this has been clear. It's a okay. Let's go to the second one. Next question, very easy. Which of the following is not a unit of time? Not a unit of time. Unit of time. Okay, so first of all, time is an independent quantity. Okay, you cannot stop the time. Time is an independent quantity. Okay, we started the lecture at 4 and right now some time has been done, 4, 5, 4, 10. So you cannot control the time. It is being independent. So first of all, now time, seconds, we all know that's an SI unit of time. SI unit of time is seconds. Okay, minute is also there, so that's a bigger unit of it. Milliseconds, much smaller unit of the smaller, milliseconds. Then what is this light year? You must have seen in the movies and in the books also, it's been written light years, 3 light year, 4 light year. The celestial bodies are in the Discovery, you must have seen it's a 400 light years away from the earth. What this light year? 400 light years away from the earth means that's the distance it's talking about. It's a unit of distance. Okay, so basically the speed of light is how much? 3 into 10 to the power 8 meter per second, or 3 into 10 to the power 5 kilometer per second. Okay, and for the year you have 365 days, 24 hours, 60 minutes, 60 seconds. So that is the duration of the time. When you multiply both of them, we will be getting a single digit, and that's in the form of the trillions, and that will be 9.46 10 to the power 12 kilometer. That's a very large distance. Okay, that's the very large distance we have. That's in a trillions. That's in a trillions. Now see, so if you just doing it, so that we can write it, 1 light year is equals to 9.46 into 10 to the power 12 kilometers. Okay, then you have one more that is called parsec, and also that's not right now, but yeah, that's also a unit of the distance to measure it. So light year is the distance, and that's the value is 9.46 10 to the power 12 kilometers. Okay, next question. What can you say about the nature of the motion of a body if the displacement time graph, the displacement time graph is also called to be the position time graph. Position time graph, same thing, is curved as shown in the figure. So as we can see, it's not the straight line. Now it's been showing distance, but actually it's a displacement only, or whatever the thing you take, displacement, that 2 in meters, and this is in time, that's in seconds. So as you can see, for each and every point you can see the time interval is equal, but the distance traveling is unequal. That means unequal distance or displacement in equal interval of time. So straight, simple is that. That's showing what? The body is in non-uniform motion. Instead of that, if it's a straight line, then it will give you the uniform motion. Speed is constant. When your speed will be constant, if you put it like this, suppose if your body is moving with a constant speed, okay, and the body is at rest, that is the displacement time graph, and this is the time. So if body is somewhere here and it's keep on there only, and the time is keeps on increasing, but the body is not moving. So this is this one. Speed is constant for every point. If you take it out, speed will come same. Speed will come same. So that is a graph for speed, or we can say velocity. Okay. If it's the displacement, then you have the velocity. If it is the distance, then you have the speed. Simple. Okay. Now let's question. The distance time graph for a butterfly motion is shown below. For how many seconds does the butterfly remain stationary? Okay. See. So what is this? Okay, Sandhya is also there. Okay. Anuj and Sandhya. Okay. So the distance time graph for a butterfly motion is shown below. for how many seconds does the butterfly remain stationary? Just now I showed you one thing. Since it's a distance time graph, yes, it's a distance time graph. In the distance time graph, so we can write one more thing. Slope of dt graph gives speed. Okay. And if it's a displacement time graph, we can say it gives also the velocity. But it's a distance time graph, it gives the speed. That means here if you see 0 to this point, okay, and it's been asking for how many seconds does the butterfly remains at stationary. So at this point it has been moving in this direction. Then for this point till here to here, you can see there is no motion in the distance. It keeps on going in that one particular thing. Okay, clear? And this is again it moved. So how much time? I just told you in the previous one graph only, when you have the dt graph like this, that means body is at rest. Whereas if you have this thing in the vt graph, that is the velocity or speed time graph, then you can say body moving with constant speed. Okay. So I hope so this much is clear. That's moving with the constant speed and that is at rest. So right now we have to find what the rest. So which one is this? This one. So this is given 2 and this is given 7. So 7 minus 2 is equals to 5. For around 5 seconds, the butterfly is at rest at that point and then start again moving. So that's for the 5 seconds. I hope so now you are able to read the graphs. Okay. Along with this question, I'll give you some more thing extra, and that's what? Sorry. So slope of dt graph gives you the speed or velocity. Clear? Slope of dt graph gives you the speed or velocity. Slope of vt graph, that is a velocity time graph, gives acceleration. Remember it. Acceleration. And another thing, area under vt graph gives displacement covered. Displacement covered. That is the area under vt graph. Area under vt graph, suppose this is a vt graph. So whatever the area it will be covering, like this one, that will be called as the area under vt graph. Okay, that will be called as the area under vt graph. So I hope so this much is been clear. So let's erase this one part. Okay, sure. Let's go to the next now. Okay, so clear. Graphs has been clear. Uniform, non-uniform clear. Slopes, vt, dt graph, acceleration, area under vt graph. Things has been clear. Okay, this has been done. This is important. You need to remember it. See, I'm not saying although you are able to see, the question seems to be very easy. But what I'm doing is I'm breaking each and every part of it, explaining you each and every part. So number of questions that can come or that can make from that particular question, I'm telling you that since we are doing the same thing from the starting itself. This we are doing from the starting itself, and that's what we are doing it. Okay, let's go to the next question now. So I've just mixed all the topics question together and then we are doing it. Okay, so in which of the following device is the magnetic effect of electric current not used? Okay, so here the topic is all about what? A current carrying conductor introduces magnetic field in it. The symbol for the magnetic field, we draw it like this one, this B vector. Okay. So current carrying conductor introduce the magnetic field in it. This is the thing. We have the question who discovered it also. So not telling you right now. After the question we maybe have it. So the scientist, okay, wait, let me tell the half name. Christian Hans performed some experiment. Actually, he was doing something else. And during that particular experiment, he found some deflection in the magnetic compass, which he kept on the table. Okay, and due to which what happened? He understood this thing, that when a current pass through a conductor, it will start to induce the magnetic field around it. If the, suppose this is the conductor and current is going in this direction. So if I want to find out, this you are going to learn in the senior classes and all. If I want to find out here, what will be the current? So here I'll go, and this one, that's outward. Okay. So for the outward field, that means around it, a magnetic field will start to induce. Around the wire, magnetic field will start to induce. And when you see it from here, so in this direction, suppose this means P and this is Q. So at this point, it will be inward field. So from here, this is the wire going. From here, the magnetic field is been moving like this. Suppose if we have this one thing, and the magnetic field will be like this. Suppose this is a magnetic field. This is the wire is having the current is going, and that is a magnetic field has been around it. Okay. So that is what is actually happening. So when a current carrying conductor introduce a magnetic field, a current carrying conductor induce the magnetic field, and that gives the whole strength or the field of the electromagnetism and all. Okay, so this is the outward. So for the outward we dot the dot, and for the cross means it's the inward. Whenever you find this dot, remember whenever you have the dot, that is the field is outward from the plane outward, and whenever you have the cross, field is inward. Okay, so in which of the following the devices the magnetic field effect of the electric current is not used? Then another thing, one more point, and that's what? Okay. Long term from Gosla campus. Okay. Theek. Okay. So see. So what is this now? This is done. Now we have the one more thing. The question may come from what now? So if we talk about the electric current shows three effects to us, and we know it. And that's what? First is the chemical effect of electric current. Then you have heating effect of electric current. And the third one is the magnetic effect. Okay, so one is the chemical effect, another is a heating effect, and third one is the magnetic effect of electric current. These are the basic three. No beta, this is 7th, 8th will be already done. You can check in the group. Okay, just go to this channel only you have been joined. Okay, go to the playlist, and you will find in the playlist the grade wise 9th, 10th and 8th and 7th. It will be there. Okay, so just check the schedule. For the physics, already we have completed it. Just check it once. Okay, Mandeep, just check it once. Okay, so now there is the chemical effect, heating effect and magnetic effect. Chemical effect, we have the electrolysis. That is when a two wire has been dipped into the water, then electrolysis start to happen. Then heating effect is the one which we are having at our homes, like iron, heater, microwave. Okay, not the microwave we can say. Okay, microwave is not, that is the different one part, but yeah, heating effect of electrons, that the coils is having the heating effect. Okay, so electric bulb we can say that's a tungsten wire and all. Then magnetic effect is the one when the current carrying conductor is there, it will start to induce the magnetic effect, like the one if you see it here like this one. So if I just make the coil like this, provide some current to it, without any key, I've made it right now, positive, negative. So the current will start to go from here, and around it what we will observe, just like the bar magnet, a magnetic field will start to induce. Okay, just like the bar magnet, magnetic field will starts to induce, and that will be shown in the around it. Okay, so which of the following is the device in the magnetic effect electric current not used? An electric bell. We have studied in the previous class. Electric bell have the electromagnet in it, due to which that particular hammer is going to attract it and hit it the gong. Okay, a heavy machine used to lift up the car, we use that. a very heavy electromagnet, we use it. Okay, then a crane to separate the iron material from the junk, that is also we are using it. But the electric iron, no, that do not use it. Okay, because it can use an alloy or the heating element. So when your current passes through it, so it starts to induce the heat. It will start to induce the heat, just like you have seen the electric bulb, the incandescent bulb. Okay, so it has the filament, like this. Okay, so when the current pass through it, so this is an alloy wire, that's a tungsten, that's an alloy properties, have the very high we can say the resistivity it has, okay, and melting point. So when the current start to pass through it, so what will happen, it will start to glow red hot, and due to which it starts to emit the light. Okay, so let's go to the next. Okay, now a general question: who found the magnetic effect of electric current? Just I told you, who found the magnetic effect of electric current? Christian Hans Sourius did. Yes, he only states that a current carrying conductor introduces magnetic field in it. Yes, Thomas Edison, we all know, electric bulb, and more are there. Electric bulb, the filament one, the tungsten filament bulb. Albert Einstein, theory of relativity and many things. Theory of relativity, which is very vast thing and very different also. You must have not knowing, many of you, that's also called STR, spatial theory of relativity, one of the most interesting and different type of the physics which you will see, and that's the theory of relativity, where there's the one thing which is being called like दो भाई थे, दोनों जुड़वा थे, एक अर्थ पे रह जाता है, एक स्पेस में चला जाता है, तो कैसे दोनों से वो कुछ साल बाद लौट कर आएगा? तो these are contradictions and are there, length contradiction, time contradictions, these are there in the theory of relativity. Okay, from here only the Albert Einstein has also explained one of the most known equation and important, that is equals to mc square. But not thus we are to Albert Einstein's the theory of relativity. Alfred Nobel, so one of the person who just been introduced the Nobel one prizes all, and the dynamite. Okay, some sort of the chemical of the glycerol salt of the chemical is being used for making a different type of the bomb, okay, which do not require too much things or all, so it can easily be used by just triggering it the button like this. You must have seen in the movies and games also, they just put the dynamite there and put the button here and it just starts to blast. Okay, that's the thing. So let's go to the now next. Jellyfish, fireflies, and the anglerfish emits the light through. So intensity, reflection, bioluminescence, or refraction. So out of these two, you must have seen the two one very importantly. Yes. So first of all, intensity. I equals to P by A. Although it's not there, but you can remember it. I equals to P by A, where P is the power of the light wave, how it's been traveling, and A is the area of it. Okay, so energy of the wave traveling, okay, energy of the wave traveling per unit area will give you the intensity of light. Okay, reflection, we all know that's a bouncing back of a light ray, bouncing back of light ray in same medium. Here where angle I equals to angle R. This also we know. Refraction is what? That's we called bending of light ray. Bending of light ray. Or we can say it's also called deviation of light ray when it passes or pass from one medium to another. And we all know one more thing in the refraction, just remember it, guys. If you are going rarer to denser, the ray of light will move towards the normal. Okay, if you have not done, see the previous class also. Okay, when you go denser to rarer, that is called rarer. This is called denser. That is the optical density, depend on the optical density of it, denser to rarer. So it moves away from normal, away from normal. So this is the part. Now what is bioluminescence? Biological, that is the living something, and luminescence means emitting the own light. There is one more thing is called that's chemoluminescence by the chemical reaction. So although the bioluminescence is the biological one term, so the like we have this bioluminescence, the fly comes, firefly, what it do? Firefly, jellyfish, anglerfish, they emit the light through the bioluminescence. That is the one biological chemical process has been done inside the body, and they emit the light, and they emit the light. Got it? And they emit the light. So that's what the bioluminescence is. So yes, the answer is bioluminescence. Clear? Okay, so I've told you all the options also. What is if the intensity comes, reflection comes, refraction comes, bioluminescence comes, then you can give it. For the refraction, you have one more thing that's called sin I upon sin R is equals to mu, or we can say n, that's called the constant. That is a refractive index basically. Okay, that is the Snell's law. That is the Snell's law. Okay, just remember it. Okay, clear? Let's go to the next now. Next question. Next question is about dash create the light by passing electricity through the specific gas at very low pressure. Although see, incandescent bulb by filament, we all know that it's a tungsten denoted by W. Take care. Gas discharge source, yes, that is the one, that is a gas discharge source. Okay, then luminescence, something like anything like a candle you take, the bulb itself, the incandescent bulb, you can take sun, that is the luminous source only. Okay, luminescent. All of the above it cannot be, because the only one is the part which are the we want the specific get at very low pressure, and that's the gas discharge source. Okay, let's go to the next now. If the angle between the incident ray and the mirror surface is 40 degree, what is the angle of reflection? Just now I told you one thing, angle I is equals to angle R. Okay, but don't ever mistaken with the words. What happens in the examination, what we do basic mistake is, this is the normal, which we all know, this is the incident ray, and this is the reflected ray. So that makes angle I, that makes angle R. Clear? Now what we basically do the mistake, this angle I and angle R has the angle with respect to normal. Always listen it carefully. Angle I and angle R has angle with normal, not with the plane of mirror. ये मिरर के प्लेन से नहीं होता है, ये इस नॉर्मल से जो एंगल बनता है ना, उसका एंगल आई और एंगल आर होता है. ये वाला एंगल कभी नहीं होगा, याद रखना. ठीक है, दैट इज नॉट द वन. ठीक, फिर एक चीज और, ये लाइट अगर मिरर नहीं होता, दिस लाइट वुड हैव गॉन लाइक दिस इन द स्ट्रेट पाथ, तो ये लाइट कितनी टिल्ट हो गई, यानी मुड़ गई, दैट इज कॉल्ड डेविएट हो गई. That comes here, that's called angle of deviation. That's called del angle of deviation. So we have done these type of the questions also in the previous classes, but not this one. This one we are doing it. So the angle between the incident ray and the mirror surface, see, incident ray and the mirror surface, that is this and this, that is 50. This is 50. Now if this is 50, if this is 50, this complete is 90. So 90 minus 50 will be what? 40. Yes, that is 40 and 50 is 90. So that is 90 minus 50 is 40. So this will also be 40 degree. Yes or no? This will also be 40. Simple. Clear? So 40 plus 40 will be 80 degree. So total angle between I and R is 80. But if you want to find out the reflection angle, angle R, that is 40 degree only. See? Wait, okay, just I have done the opposite. Sorry, my mistake. I have taken the mistake. I have just put it the 40 here and 50 there. Okay, no issues. It's the same thing. Concept is same, just I put the values different. I have taken 40 here. So this is 50. So that will become, okay, sorry, again I am writing 50. Why? What I am doing? Wait. Sometimes happens this also. So this is 40, now this is 50, this is 50, and this will again 40. So 90 plus 90 will be 180. Okay, so that's 40, this 50, and the same. Same concept, same thing. Same concept, same thing. Yes. Yes, Anush. So answer is second one. Yes, B. No, not A. B one. Yeah, 50 degree. Okay? Why? Because we have to find the angle of reflection. Angle of reflection means this one, angle R. Angle R we have to find. That is the reason. Okay? Previously, what I have done, I have taken this as a 50. So obviously that will come 40 only. So answer was correct if I have to take the values. But question is given for that 40 degree, na? With the surface. Now remember, it said with the surface, this one, not this one. If it's given with the normal, then only you have to put it like that. Okay? So that is clear. Let's go to the next now. When the light passes through the convex lens. Okay, so we have the two types of the lenses, basically. Okay, so one is this one. That's convex, and one is this one, that is concave. So obviously we know convex is the converging. Convex is the converging. Whenever the light goes, it gets banded. We have the same lens in our eyes also. This eye, you will see the lens in the eyes, convex only. So whatever the light comes, it goes straight and just converge over it and falls onto the retina. Falls into the retina. Okay? Yeah. So that's one which will be the answer. All you are active right now. Yeah. What is the answer right now? First, second, third, fourth. Yes, 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 correct, correct. So name Akhil, Aradhya has given correct, very good. Anuj given correct, good, very good. Yes, once only you give the answer, that is correct. Okay, so yes, that is the third one, because the convex lens is converging. And the same lens we are using in our eyes also. In the eye also we have the same type of the lens. Remember, in the same type of lens we have in our eye. That is, it bends inward, and converges. So whenever the light goes from here, comes from here, light comes from here, it always just converge. Okay, I'm just giving you a rough idea on it. Okay, it converges. But for this one, it goes diverging. So it's a diverging one. Now, where you get confused is with the mirrors. Mirrors are opposite. Mirrors are opposite. Mirrors, you have concave and convex. Concave one is this one, where the outer part is polished, and convex is this one, where inner part is polished. So this is the reflecting, this is the reflecting. So concave is converging mirror, and convex is diverging. Just remember, in the mirror it is different, just opposite of it. In mirror it is different, it's just opposite of it. Okay, clear. Let's go to the next now. Here come the assertion and reasons. Yes, that's depend on the chapter number heat. Mercury is used, that is Hg. Mercury is Hg. Okay. Mercury is used as in a clinical and laboratory thermometers. You must have seen during the fever and all. Your parents have put it on over your tongue or on your armpits or something. Okay, so you can see there is a very silvery touch color is there at the bottom of it. Okay, very at the bulb, which is called the bulb of the thermometer. Then you have the kink of the thermometer, which help it to doesn't fall it directly. The question may come from the kink from the bulb. So I just told you, mercury is Hg. First of all, it's a liquid metal at room temperature. Liquid metal at room temperature has very good density. Has a very good density. Yes, Anuj saying second, Akhil is saying one. Okay, Anuj saying second and Akhil is saying one. Wait, we are coming it. Mercury does not wet the glass and has the high boiling point and the low melting point. Yes, low melting point. Why? Because it's already liquid at the room temperature, na? It is already liquid at the room temperature. So that is correct. Mercury is used in it. That is true. Mercury does not wet. Does not wet means if you take the glass, fill it with the water and just empty it again. So will you see when you put the tissue over it, over the glass, when you empty it, then also you will see the tissue will still got some sort of the wet, some particle of the water is still be attached to the tissue. This we have seen it many times. But when with the mercury, if you just see mercury, when the temperature rises, the mercury rises up because metals on heating expand. That is the topic. Metals on heating expand. That's why when it starts to expand, at that point, what will happen? It goes up, and when it slows down, then it comes down. It won't even a single drop will also be touched at the top or another surface. So it does not wet. That is true. It does not wet it. It has boiling point. Yes, it has. Good density, high density also. Low melting point. Yes, that is also true. So both A and R is the true one. So option number A given by Akhil is correct now. Anuj is given to Anuj. Second is not the correct one, beta. Okay, because both of them are true. Okay, and that's the correct explanation of it. Okay, you can say that, but the actual me why we are using in the clinical or laboratorial purposes, because of the reason of this one only. Okay. Okay, here comes the numericals. Okay, so what would be the value of the room temperature of 298 Kelvin on the Fahrenheit scale? Yeah, try to do it faster, everyone. See, we have the three major scales. That is the degree centigrade, Kelvin, Fahrenheit. Right now we have to find in the Fahrenheit scale, okay? And values given in 298 Kelvin. Okay, so Fahrenheit is equals to 9/5 degree centigrade plus 32. This is the formula we have. We need to convert that Kelvin into Fahrenheit. Yes, 77. Yes, correct. Very good. 77 is this. Let me just solve it again for everyone. So we cannot put directly. So for that we have Kelvin equals to 273.15, or we can just write it down like this directly. No issues with that. And that's what degree centigrade is equals to how much is given? 290. That is K minus 273.15. Okay. Right now that is the value of Kelvin. We have it with us. Okay. But the thing is, we don't have to take it point right now because the answer is not coming in point. So we can do it directly also. So degree centigrade, Kelvin is how much given? 298 minus 273. Direct I am doing it. 98, 73. 2 will be same. 8 minus 3 will be 5. 9 minus 7 will be 2. 25. 25 degree centigrade is the answer for this one. Let's put it here. That is 9/5 into 25 plus 32. 5 times 45 plus 32, that will be 77 degree Fahrenheit is the answer. That's true. You can do it directly also. See, one more formula. Let me show you directly. If you have to find C and K along with this one, na, just you can write it like F 9/5 K minus 273.15 plus 32. That is the answer, or that is your direct formula. You can write it down for this one. Clear? I hope so. This much is clear. Yes, 77. Guess correct. Very good. Akhil and it's Akhil and Aradhya. Okay, creative world. TK. Okay. So let's go to the next. 200 degree centigrade. Yes, do it faster. 200 centigrade. Faster. Okay, we got the answer. Hi Anuj. Hi. Hello. Good evening. Answer, Anuj. Answer. Along with it. What will be the answer? Akhil is saying 2. Okay. Akhil Aradhya is saying 2. What about the others? 200 centigrade and Fahrenheit. Faster, bhai. Anuj is also saying 2. Okay. 228. Let's see. Let's see whether it's a 228 or not. Fahrenheit. Again, same formula. 9/5 degree centigrade plus 32. So F is equals to 9/5 into 200 plus 32. 40. 36 plus 32. How? That is this one. 392. Option number 3, beta. See? Got it? Yes. Got it? This is a simple formula we have to do, nothing else. ठीक? Okay? Yes. No, Anuj, not 2 beta. Okay. Yes, the answer is 3. Yes. Chalo. Okay, for the previous one. ठीक है. Got it. Next question. What is the temperature at which the Celsius and the Fahrenheit scale becomes equal? That's a good question. At what temperature at which the Celsius and the Fahrenheit scales becomes equal? This we have to do. है ना? We can do it. No issues. So it's saying at what temperature F becomes C? At what temperature? It's asking. F becomes C. Okay. We know F is equals to, let's change the color, make it more highlighted one. 9 by 5 degree centigrade plus 32. So if we want to say F equals to C, let's put the F equals to C then. So C is equals to 9 by 5 degree centigrade plus 32. Clear? Got it what I have done? Yes, third is correct. Third is correct. Very good. Third is correct. Minus 40. It will come. Let's solve it first. Okay, so this will be there. So C minus 9 by 5 C equals to 32. That will be 5C minus 9C upon 5 equals to 32. 9 minus 5 will be minus 4 upon 5 and that is C equals to 32. Minus 4C is equals to 5 2s are, that is 32 into 5. Yes. And then we'll get it C equals to minus 32 into 5 divided by 4. Yes. 160 40 minus 40. At minus 40 degrees centigrade, at minus 40 degrees centigrade, we are getting the answer. Okay, got it. Okay, done. Okay, let's go to the next one. The time period of the pendulum is defined as, already we have done this one, part of it, but let's see. The time period of a pendulum. Just watch the previous session, guys. Third, time that is taken by the pendulum to go from one extreme to the another extreme. Okay, the number of the oscillations completed by the pendulum in 1 second, the time taken is by the pendulum to complete one oscillation, or the number of the rounds completed in 1 second. See, time period is 1 upon frequency, or frequency is 1 upon time period. Okay, both are things, both are inverse to each other. The most appropriate answer will be, most appropriate, I want most appropriate. The time taken by the pendulum to complete one oscillation. Remember, yes, exactly. Now you got it. Yes, Anuj and Akhil. Okay, not Anuj, second one, beta. Just give once now. Why to give it 3 or 4 times the same thing? Okay, so the time taken by the pendulum to complete the one oscillation, because whenever you are finding the frequency, so what is the frequencies? Number of oscillations complete in 1 second, that is a frequency. Number of oscillations complete in 1 second. No, Anuj, it will be this one only, beta. The time taken by the pendulum to complete one oscillation. How much time the one oscillation will complete, that is the one. Okay? Next question. Convex mirror are used in the street lights. Concave mirror are used as the reflectors in the headlights. Let me just show you one thing for the convex and concave mirror. Convex mirror has been there, na? If convex mirror is there, is the street light. Street light, we want what type of the things we want? We want to cover the larger area. We want to cover the larger area. Is it correct? Which one is the correct one? Your answer is 2. Okay. Just give it once, na? Both of you. That will be good. My name is Sachin. Yes. Okay, my name is, what is his name? My name is Sachin. Okay, okay, that is good. It's Sachin Acharya, complete name. Okay, so the statement is convex mirror are used in the street lights, then concave mirror are used as the reflectors in the headlights. Okay. Obviously, in the headlights, you need to see the far away distance, na? And so that, because of that, what we want? No, it's not 4. You are writing 4. No. See. Concave, what concave do? concave converge. It's a mirror beta, it converge and it diverge. Okay, for the street light you want the wider area na from the street light, so it's doing the same thing for the reflectors in the headlights. Suppose these are the reflectors, here you held the bulbs, it goes like this and goes like this parallel, so it can go it for the longer distance, it can easily go. Both is true, both is true, see it, both A and B are true. Convex mirror, it's not concave, it's convex mirror used in a street light. Yes, it wants to diverge, it wants to diverge. No Anuj, it's first beta, it's of both A and B are true. Why you are saying 3? Why A is true, B is false? How? Concave mirror beta, in the reflectors we want the larger distance can be traveled by the parallel beams. Okay, you are not understanding then. See, so this is the one with the concave convex and this is for the concave one. So both A and B are the true one. Okay, yes. Okay, the properties of the image formed by the plane mirror are, so these are the basic properties we know. Plane mirror form the virtual image. Yes, virtual images are erect. Erect means upright. That is true. They are inverted or laterally. They are literally inverted. Yes, that is true. Not inverted, that they are literally inverted. Not inverted. So which one is the correct one? First, second is correct, fourth. First, second and fourth. Option number 4th is the correct answer. Okay, they are literally inverted. Virtual and erect, that is upright. Okay, clear? Let's go to the 17th. How many meters does the Falcon cover in an hour if he travels at the speed of 320 km/h? Very easy question, nothing you have to do. So we have the speed 320 km/h and the time is given 1 hour. So distance is equals to speed into time. Speed is 320 into 1, that is 320 kilometers. Okay, but you need the answer in the meters. So we know 1 kilometer is equals to 1000 meters. So it will be 3, 2, 1, 2 and 3. So that will be in the meters. So this is the answer. Now an additional part of it, 1 kilometer equals to 1000 meters. 1 meter equals to 100 centimeters. 1 centimeter equals to 10 mm. Okay, this is the part. So just do the reverse of it. That means 1 meter equals to 10 to the power minus 3 kilometers. 1 centimeter equals to 10 to the power minus 2 meters. 1 mm is equals to 10 to the power minus 1 centimeters. Okay, just remember these parts. Just remember these parts. Clear? Okay, so yes, answer is 3. Sorry, my mistake. Answer I have taken the correct. It's this one. By mistake, and I have just added this 3 to 4 times 0. That is 3 to 4 times 0. We have our answer same, only I have just put it there wrong. Okay, so time period of the pendulum is longer when the length of the string is. See, if you take the shorter hand and move it, so it goes like this. Okay, only this much is the length. Suppose this much. And if I just take it this one, see, getting it? So the time period of the pendulum is longer when the length of the string is longer. One more question can come with respect to this one, and that's the summer and winter one. Summer and winter. When the pendulum will show the more time as in summer or in winter. So in summer, basically the length of the pendulum get contract, and in winter, in summer it just got extend because expansion and heating. So it just expand. If it expand, that means length increase. Length increase with respect to the winter. So time period will be more in summer as comparison to the winter. Clear? And we got a time is equals to 2 pi under root L by G. And from here also the T is proportional to L. That means length increases, time period increases. Length increases, time period also increases. Okay? That's the longer. Let's go to the second last question of the session. Okay, so that's what the minute hand of the wall clock is 10 centimeter long. Okay, minute hand, that's the longer one length of the clock. Find its displacement and distance covered from 10 a.m. to 10:30 a.m. That is, it's a a.m. only. Okay, so suppose let's make the clock. That's 12, 1, 2, 3, 4, 5, 6, and that's a 6. Okay, and here Clear? 9 and 3. So for making the 10, suppose here is the 10, smaller one and the bigger one, that's 10. Then it's gone to 10:30. That means it's going to 10:30. 10:30 means this 10 and this 30 minutes. So it just traveled like this and it comes here. Clear? The length is given to us 10 centimeters is longer, but we can take as the radius of it. So this is 10, this is 10. Suppose this is at 12 and this is at 6. So the displacement is initial and final. Initially it is here, final it is here. What is the displacement? The shortest distance between the initial and the final point. Simple. Initial and final point, 10 and 10, 20. That is 20 centimeter is the displacement. Okay. Then what will be the distance? So distance is the over the circumference. Distance is the over circumference. So since you can see it just covered the semicircle of it. So this complete circle circumference is 2 pi r. So here we have the half of it. So 2 pi r by 2. So it will be like pi r. R is how much? 10. So it will be 10 pi centimeter. So the answer we have it 20 centimeter and 10 pi. Not centimeter we will not use. We will use the pi directly. So just write it down here. Or that's the centimeter also. We can say it. No issues with that also. So it's the answer is 20 10 pi. Answer is 20 10 pi. Yes, correct. B is the correct one. Very good, Akhil. Final point, your what are you writing? Leave it. Okay, so next, last question of the session. Okay, very last question. What is the effect of increasing the current in the wire on the strength of the magnetic field around it? So in the starting question we have just seen it. When a current passing through the wire, the magnetic field around it starts to increase, or we can say the magnetic field starts to induce basically. So if I increase the current, then what will happen? So there's one thing which is called B is proportional to I. That means B is the magnetic field and I is the current, and this is the magnetic field. Okay. So as you increase the current, magnetic field will also increase. So the magnetic field strength will remain same. No, field strength will increase. Yes. Option number B. Yes. The answer B. Yes. Correct, Akhil. Akhil, Anuj, correct. Very good. Very nice. Very good. So that is what? That is the magnetic field strength will increase. Got it? Because B is proportional to I. B is proportional to I. Okay. How we got it? This is the point. When a current carrying conductor have the current, or current carrying conductor is there, around it a magnetic field will starts to induce. Magnetic field start to induce. And the previous question I told you, if it is being shown by this dot, then it's the outward, and it's been shown by the cross, then it is inward. Okay. Okay, everyone. So I hope so. Today we have done around 20 questions. In the previous sessions also, if you go and see the playlist, it will be there. So my answer is the magnetic field strength increase. Yes, that's correct, Akhil. That's why I said it. I already take the name. Yes, it's correct. Okay. So don't forget to register. Exam dates are 28 September and 12th of October. You have to register. For registering it, you have to go to srichaitanyasco.com. That the link is given in the description. You can go through that. Like, comment, share. You can do it. Yeah, you know it already. Just you see go to the YouTube. You have the playlist. Open the playlist for the grade 7th. Whatever the sessions you can see. For the physics I'm taking and for the chemistry bio, everything has been there. So just go through the topics and all, because not only the questions, like the way you have attended the class for the today, I think you have seen the recorded session also the previous. If not, then see it. For each and every question, if they're asking it very easy also, then I've taken each point of it and explained it thoroughly. So your complete revision for the class 7th has also been done. First thing, and the next thing is you have been already prepared for this one also. Registration kar rakha hai. Okay, that's very good. Kar rakha hai. That is very, very good. So for the class 7 exam is on 28 September 2 p.m. right? Yeah, that once you have registered kar rakha hai. Okay, very good, very good. ठीक है? ठीक है? So register कर रखा है ना, तो register करने से अच्छा है वो उसमें मिल जाएगा आपको. ठीक है? You will get the timings and everything. You will get it. ठीक है? So you can follow us on the Insta and everywhere. ठीक है? Clear? So that's all for the session, guys. So I hope you have enjoyed the session. Okay, please do the practice and best of luck for your score examinations. Okay, so we'll see with the results and everything. And I hope so you all get the good scholarship and all. And the NASA trip, which is my favorite one. Okay, so bye everyone. Bye, 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 bye everyone. Okay, bye, bye Akhil. Okay, this Akhil is there and Anuj. Yes, bye Akhil and Anuj and Ramant. Yes, bye, bye everyone and everyone. Those who will see the videos. Okay, bye.